Recording. All right. So I'm also gonna record this because Ollie has asked me to record this meeting as well. I think for if anyone wants to watch it in the morning. Um, so there's that. So, all right, there's actually a
Yeah,
lot.
what is happening?
Wait.
All right. Um, okay. So, welcome to the specialist masterclass. I'm Oliver Yang, so I graduated from Somerset College in 2023. So all right. So I'm guessing
Muted.
can first of all, can everybody hear me? Just like you can just
Yes.
unmute and should be all good. All right, cool. Okay. So I'm sure you guys are pretty nervous for specialist tomorrow, but you guys honestly should be fine. Um, most of the questions that we're gonna go through today are actually, I guess, quite hard. It's something that you would expect as, I guess, complex level. There are some questions where are quite okay. But yeah, it's those pretty high level questions, I would assume. All right, so why don't we get a start? So here are the topics that I'm going to run through today. Proof by mathematical induction. I'm going to just assume you guys are okay with that because that's usually I guess it can get very hard, especially if they throw in like a trig one. But if you like step it out correctly, you get majority of the marks. It's just like the prove and equals k plus one might be a bit harder than or just a bit hard in general to do. And then obviously dominance and Leslie matrices. I'm assuming you guys can hopefully do that. So yeah, just make sure Leslie matrices, your fecundity is on the top row, and then your I think it's on the uh survival rate on the diagonal. Okay. So we'll go through we'll just get on the start now.
Wait,
All right.
wait. Oliver, was fecundity the birth rate?
Yeah. So I'm pretty sure that is from memory. That's what Leslie matrices are. And the dominance obviously is about influence over others. So yeah. So make sure to just to know your first and second order, what they mean, stuff like that. It should be all fine. Okay, so here's a proof by math induction. I don't expect you guys to do this. It's quite cooked. So you guys can take a picture of this. We won't do it because I don't think they will give you something as hard as this, and we can just move on. So just let me know if you guys are all good with regards to just taking a photo and why are you looking at system of linear equations? Okay, that's weird. There we go. Can you guys? Oh, there we go. So proof by math induction. There we go. So just take a picture. Just do it later for yourself. I'll upload the solutions. But we won't go through it tonight. I think it's a bit cooked. So yeah. Uh, um, all right. Okay, so that's something that probably wouldn't come up on the exam. I don't expect QCAA to be that harsh. But if you can do this, you basically can do anything they throw at you. So, yeah. Okay. Why don't we go to system of linear equations? So let's do that. So here's the first one. Have a go at this. Right. All right. Why don't we get a start on the solution of this? So obviously we're asked to do a augmented matrix. So why don't we start with that? So we've got a 3 by 3 here. The coefficients just go in the columns. So the coefficients of x, y, and z go in these columns respectively. So for our first equation, we've got y plus 4z. And so that would be 4, 4 here. And then well, sorry, that's my bad. That's not 4 there. 4 on the z, 1 here, 0 here. And then we keep going. So 2, 0, 2, 6, 0, and then 1, 2, A, and then B, 12, 7. Okay. All right, so let's do it to row echelon form. So that means row echelon is just the ones on the diagonal, well, in this corner here. That's what row echelon is. So let's just do that. I just rubbed out the 2, didn't I? Yeah. Okay. First step, because there's already a 0 in this top left here, we can just let's just move the row to the very bottom. So why don't we do row 1 to row 3, and then so that becomes we'll switch them. So 1, 2, A, oops, A, B, and then 2, 6, 0, 12, 0, 1, 4, 7. Cool. And then we'll keep going. So our next step will probably be to get this number here to be 1. And then, oops, I keep rubbing out stuff. My bad, guys. So we'll go row 2, and then we'll write row 2 minus 2 row 1, because we want to make this 2. So this second 2 here becomes 0. Make this rather smaller. And then, so let's do that here. So we'll get 1, 2, A, 0. And then so row 2, 6 minus 2, that's 2 here. And then we have row 0 minus 2A. So we get minus 2A here. And then we get row 2 minus 2 row 1. So that will be 12 minus 2B. 0, 1, 4. All right. And so the last step here would be getting a 0 in this row here. And so what we can do is we can switch it back again. So we can switch row 2 and row 3, and then we can minus it from row 1. So what I mean is, I'll step this up for you guys. So we get top row stays the same. So it'll be 1, 2, A, B. And then let's just switch these 2 rows here. So we'll go 0, 1, 4, 4, 7, and then that will be 0, 2, minus 2A, 12 minus 2B. And then so let's just cancel the last 2 rows. So we get the lower triangle to be all zeros. So yeah, let's do that. So that's A. And sorry if my handwriting's a bit messy. It's just like so our row operation will be row 3 equals row 3 minus 2 row 2. So this stays 0. This becomes a 0. Negative 2a minus 8 is just negative 2a minus 8. And then we've got 12 minus 2b minus 14, I believe. So that would be negative 2 minus 2b. Okay, so here's our row reduced form from our augmented matrix. And then so we're asked to determine the values of A and B, which the system has no solutions, unique solutions, and infinite amount of solutions. Okay, so for no solutions, we should know that that means when we have something 0, 0, 0 and a number here, like 2, right? Because you can't have 0 equals 2. So that's just no solution. So we're looking for A and B to, well, B be a number that's not 0. So for this last row here, this just needs to be any number but 0. So we can just do minus 2b equals 0. So negative 2b equals 2. So b equals negative 1. So b can't equal negative 1, right? So for I, no solutions. B can't equal negative 1. And then for A needs to be, so this equation here needs to equal 0. So that would be negative 4. So A can't equal negative 4. And so those would be your no solution answer. If anybody like disagrees, please let me know because I do make mistakes. So yep. But other than that, that should be your solution for no solutions. Is a unique solution. So that means when we have a column of 1 here, so this needs to be just, I guess, any number but 0. And then this number here needs to be just a number, any number that you want. So all real numbers, right? So in this case, we can have a, oh, if I made a mistake, I feel like I have a mistake for no solutions. Oh no, no solutions would be A, B equals negative 1. And then, okay, yeah. Okay. Um, sorry, am I like just have I lost everyone? Shouldn't A equals 4? Yes, so A equals 4. Yes, no, I'm wigging out actually. A equals A is 4 for known solutions plus infinite solutions. You're right. Yes, that is true. But A should be negative 4 because that would make this 0, right? Because it's negative 2A minus 8. So two negatives, that's 8. 8 minus 8 is 0. And then so B equals negative 1. That should get you a no solution answer. A unique solution would be unique solution. A equals anything but negative 4, right? So A is, you can rewrite this, A is a element of reals, but except negative 4, right? And then B can just be anything, right? Yep. So that's that. And then for infinite solutions, it would be A equals negative 4. And this case, B has to equal B should equal negative 1. This is B is not equal to negative. Yes. So here. So that should be your solutions because for infinite, this should be a row of zeros, right? And then for no solution, the your coefficients matrix should all equal zeros, but this one can just be a number, and that would be no solutions, right? And then, yeah, and the unique solution would be just where A doesn't equal, where this part of the augmented matrix doesn't equal zero. It can be any number but zero. And this part can be just any number, and then you'll get a unique solution. Okay, so that's probably how hard systems of linear equations can be. It's just yeah, just know your no solutions, unique solutions, infinite number of solutions, and should be all good. Other than that, yeah. Is there any questions with this question? Like, no, yes, maybe. Okay, I'll repeat the rules. I'll just write like a general kind of thing. So if we have a matrix, the rules are, so a unique solution kind of looks like just um right. So this would be an example of a unique solution. Obviously, don't back substitute this because I know it doesn't work here, but you want to see like basically not anything but zero in this column. And so you'll get a unique solution, right? So this is unique. Um, infinite kind of looks like this. So let's just do the same thing. So infinite solutions. So that's like that. And then no solutions. No solutions kind of look like this. Right? Where we have a row of zeros in this coefficient area and 3 as our answer. Okay. So, all right, I'm happy to move on now. Okay, vectors and planes. So, yep. Have a go at this.
When its class finishes, I have no idea. Did not say.
Gideon, turn off that mic.
No, no, no.
All right. So, vectors and planes. Okay, why don't we go through, because there's actually a lot of questions that I want to get to today. So, vectors and planes should be your okay. All right. Sorry, God. Sorry. That's my bad. That's my bad. You guys can write it down first. Just let me know when you have finished writing it down, and then we'll go through. Was the spec final hard when I graduated? There was some, there was a pretty bad complex number one, I remember. That one was pretty bad. But 23, I think it was a bit harder than 22. So all right. Have we written down question two? Yep. Yeah, I did make the chess AI. Yeah, that was about 2 years ago. Yeah, that was me. Anyways, let's do that robot didn't work. Yeah, no. Okay, anyways, so it's more like the mechanical part didn't work, but the actual like computer did. But anyways, so let's do vectors. So let L1 be the line passing through AB and L2 to be passing through AC. So we can tell that AB and AC are going to be your direction vectors of your line equations, right? So A L1, so in the form of R equals R0
Okay.
plus, let's call this vector B V1, where T is a parameter, right?
Sandwich type noodles type
Artava, shut up.
Shut up.
snack bar snack
Whose
snack bar
mic is that one? I might just mute them. Okay, it's all good. It's all good. All right. So V1 obviously here is your vector made from these 2 points, and obviously that would be negative OA plus OB, right? Because A and B are points, so they're position vectors. So why don't we do that? So 0, negative 0, 1, 2, plus 2, 3, 3. So 0 plus 2, that would be 2. Negative 1 plus 3, that's 2 as well. And then negative 2 plus 3, that's 1. And then, so, okay, so that would be a direction vector. And then, so let's find the direction vector of V2, because that's all we care about. So that's between AC. OA plus OC. So that's negative 0, 1, 2. Plus OC is 5, 4, negative 2. And then again, this would be 5. This would be 3. This would be negative 2 plus negative 2. That's negative 4. Okay. So let's find the angle. So obviously we can do dot product. So V1 dot V2 equals cos, oops, I'll write the magnitude of V1, V2, cos theta, right? So why don't we calculate the magnitudes as well? So that would be the square root of 2 squared plus 2 squared, that's 8, 9, root 9, that's 3. V2 is, let's see here, 25 plus 9, not plus 4, that's very not working.
Plus
34,
16,
38.
bro, plus 16.
Plus 16. Oh, 16, yeah, my bad. Plus 16. There we go. So that should be 41 root 50, I believe. Okay, cool. So we've got our 2. We'll just sub it in. Let's do the dot product. So dot product between these 2, 2, 2, 1, dot 5, 3, negative 4 equals 3 root 50 cos theta. That'll be 10 plus 6 plus negative 4. So that's 12. And then, so we've got 3 root 50 cos theta. And then just do cos inverse, and that should get you your angle. So that should be 4, 4 root 50. It should simplify to something, but I just can't be bothered. Do we understand how that kind of works? It's pretty, like general stuff. All right, let's add a page. So, okay, how do we find the Cartesian equation of P? well, we know that the plane cuts through all of these points, right? And we've got these two vectors, right, that are on the points. So we can just do the cross product. Right? So let's do the cross product of these two. So it's just the determinant of I. Whoops, my bad. I, J, K. 2, 2, 1, and 5, 3, -4, which is equal to I 2, 2, 3, -4 minus J 2, 1, 5, -4, and then plus K, which is 2, 2, 5, 3. Okay, let's just do the determinants of these. So
I's are 2, 1.
2, 1, yes. Thanks. Thanks for letting me know. Okay, so why don't we do this? So the I component should be -5I, and then it should be the J component should be the -8 plus 5, and then plus K is 6, not plus 5, it should be -5. And then K should be 6 minus 10. So your normal of the plane, right? Your normal of the plane should be -5I plus 13J minus 4K. Right? Everybody got that?
Is it not -11I?
Yeah, that's what I was gonna say.
Yeah, I got 11.
Shit. Yeah, no, you guys are right.
Me too.
Okay. 11I, and then plus 13J minus 4K. There we go. So that's our normal. And then so we know our plane equation P, R dot N equals A dot N. Just select any point, and then so our R will be -11x plus 13y minus 4z equals, let's do the dot product of 2 points here. Pick one, let's pick A. So 0, 1, 2, dot with -11, 13, -4. So that should be 0 plus 13 minus 8. So it should be 5, right? So that should be a plane equation for P. Okay, cool. All right, so find the vector equation of L3 which passes through B and is perpendicular to P. So we know well, a line that's perpendicular to the plane is just the direction vector of that line is going to be the normal. So we can say N equals V3, right? Which is equal to -11, 13, -4. And then so passes through point B, well, we're just going to put the point there. So we can say L3 is equal to B plus E3T, where T is a real element. And then so our point for B is 2, 3, 3 plus -11, 13, -4 T. And so that should be your line equation, I'm pretty sure. Okay, some questions I've seen, they put T instead of lambda. No, T, so T and lambda, yeah, you can put any symbol that you want. Because they're just parameters, right? So, okay. All right, is everybody happy with this question? Yep. Okay, cool. All right, let's go to this next one. So we'll start complex numbers. This will probably be a hard one. It's a graphing one. So like to go back? Okay. Yes, I'll upload full solutions at the very end. So yeah. Okay. I'm assuming we're okay with that. I'm gonna go to the next question, complex numbers. So most of these questions are gonna be tech free because what I think is like if you understand the pen and paper parts, you should be okay with the tech active as well. Just know your calculator quite well. So yeah, there will be a calculator question. So the locus of P is just, yes, it's a subset. So right. Are we looking for? Cool. Okay, let's make a start on this because it's quite hard, I guess, in terms of like you will not get this as like a multi-choice or anything like that. That'd be probably one of the last questions you get in your exam if you do get this. Okay, why don't we start? So first of all, we'll be given that z equals x plus yi. So why don't we just sub it into this entire equation so we get something out of it? So arg of oh well, why don't we just do let w equals z plus 1, z plus 2, right? And so that would equal x plus yi plus 1 divided by x plus yi plus 2. Okay. All right. So then if we wanted to like expand, like basically get them all together as one, or just make it expands to zoom out for a sec. All right, here's the question. Okay, so yep, okay. So we wanna factorize. So it will become x plus 1. Yes, so we want to multiply by the conjugates, right? Yes. But I'm gonna get the real components together first, so it's a bit more clear. And then so we multiply by the conjugate. So that will be x plus 2 minus yi. X plus 2 minus yi. Whoops. Okay. And then once we multiplied that, which is going to take a while, you do get, let's just make this together. Ooh, yes. There we go. You do get x plus 1. Okay, that was unexpected. X plus 1 plus yi. Oh, no, let's just expand it quickly. So we'll do that'll be x plus 2 plus y squared, and then divide by x plus 2 squared plus y squared. And then we've got the imaginary components on this side. And so if we expand this, this would get x plus 2 minus y plus x plus 1. And then x plus 2 squared plus y squared. All right, cool. Now, when we also know from the initial conditions that we've got an angle of pi on 2. Pi on 2 is just 90 degrees. So if we kind of have a look at the graph, this arc of w, if we just consider w as some function, we know that the real component is going to, the real of w is going to equal 0, right? Because we're just going up on the, that's kind of thing. And then imaginary of w is greater than 0. So that's kind of the thing here. So, and then we just separate and take the real components and the imaginary components. So
Sorry. Can you go back a step and explain what you did with the whole right-hand side of that fraction
oh, the right hand side of this
after the
thing.
I?
This thing here, this big.
Yeah. That right-hand side with the whole y over y times x plus 2 minus yx plus 1. Where did you get that from?
Oh, when you expand it, you get the whole thing. And then you factorize it out. So I can show you the whole thing, but it's gonna take a while. But I just want to kind of get through to doing, I guess, the conceptual part of this question more like, because you really wanted, okay, let's do the whole thing. It's just we've got like a lot more questions to go through, and I kind of don't want to spend a lot of time on this. But do you guys understand what to do? That's the main part. Because if you're okay, it's just an expansion. All right, cool. So the real component equals 0, imaginary component of w equals is greater than 0. Because if you've done your rays and stuff, that's that. Okay. So therefore, let's just take the real parts. So that would be well, we know if that's the real part, so then x plus y, well, not y, x plus 1, x plus 2 plus y squared, that's equal to 0, because we originally had the fraction, but all you do is multiply the fraction out to there, and then so we're left with this, right? And then so if we expand that, that's going to be y squared plus x squared plus 3x plus 2, which is equal to 0. And then we can complete the square for this. So y squared plus x plus 3 on 2 squared minus 9 on 4, 2 equals 0. And then well, we can just finalize this. So we have a circle equation basically. Equals 1/4. Our radius will be a half. Okay, and then we also need to take care of the imaginary parts, right? So from our equation above, this would be y x plus 2 minus y x plus 1. And then so that will equal 0 as well, because this denominator here, if we let it equal, we'll multiply it out, becomes 0. So that's kind of the whole gist. Well, greater than 0 actually, because we know that from our conditions previously. And then so this will be yx plus 2y minus yx minus 1y. And so we know that the y component here is going to be greater than 0. right? So when we want to graph this locus, right, it should be just half of a semicircle because we know from our condition that y is greater than 0. So, sorry, no, yeah, so just a semicircle, not a full circle. And so if we want to graph this, we can go out to -1, and then we've got -2, and then we have this, right? Half a semicircle, kind of like that, with the middle being -1.5. So 1.5. So, and then that's our Cartesian plane. So yeah, because, x plus 3/2, because it's plus, we move it to the left. If it was minus, we'll move it to the right. Y, there's no vertical, what's it called? Movement. So basically, yeah. All right. Okay, so that's that complex number question of graphing. So yeah, I guess the to take away from this question is just if you get something like this, just sub in x plus yi. Because like that's normally what they wanted you to do. It's, yeah, you just expanded everything. Any graphing question, if you see like something about the locus, I would recommend just doing the strategy and going ahead, expanding everything, doing this. So, all right, cool. Why don't we go to the next complex number question? So we're using the Moivres to do an expansion. So normally you would see this, you probably use Pascal's triangle because that's pretty easy to do. Yeah. Okay, so why don't we have a go at this?
Wait, sorry. Are you able to just quickly scroll up to question 3? I'll just take a screenshot of the working.
Yeah, all good. So I'll delete that. Probably put this up together. Here's the graph at the very end. There we go.
Thank you, bro.
No, it's all good. Okay. So why don't we go to the next one, complex numbers using Demoise's. Okay. Let's just get a start on this one. So we know that sine 5 theta, we can rewrite this as cis 5 theta, but only consider the imaginary element of this equation. So we'll do this without considering it first, and then we'll add in it later. So this will, if we expand this using Mars, what's this? Cos theta plus sine theta. That's the bad handwriting. To the 5. And then so that will be cos 5 theta plus I sine 5 theta. Right? And then so we can use the let's just take the imaginary of the left-hand side of this cis. So that'll be sine 5 theta. And then we can expand the right-hand side. So that will be like expand this whole thing. I would do it. So we can do Pascal's triangle if you want. So that would be from memory 1 2 1 1 3 3 1 1 4 6, 4, 1. And then 5, right? So 1, 5, 10, 10, 5, 1. Okay. So let's expand this entire thing, which is basically just hell. Let's do it. So cos theta plus sine theta 5 equals. So the first one will just be cos theta, cos 5 theta, right? And then we will plus 4, well, and then it will be 5, right? Because that's the coefficient. So the second one will be 5 cos to the power 4 theta sine theta. And then remember to include the I, because oh yeah, because there's an I here. I have completely just not added that. So there we go. So yeah, you'll get I here, and then we'll continue. So the next one would have a coefficient of 10, and we keep going down. So it should be 10 cos cube theta sine squared theta I squared, right? The next one will have another one. So another 10 cos squared theta sine cube theta I cubed, right? And then plus 5 cos theta sine to the power 4 theta I to the power 4. And the last but not least, we've got sine 5 theta I to the power 5, right? So once we expand that, I'm just going to simplify it now. So we've got, because we've got a bunch of i's in here, so cos 5 theta plus 5 cos 4 theta sine theta I plus 10 cos 10 cos cube theta sine theta. Well, because this is I squared here, we're going to make it a negative because I squared is -1 plus 10 cos squared theta sine cubed theta. And this is I cubed, so it's going to be -I. I'm going to write it at the end. And then we've got 5 cos theta sine 4 theta. I to the power 4 is just 1, right? Because I squared is -I times -I. Oh, sorry, -1 times -1. So we get that. So that just stays the same. And then sine 5 theta, that should be just I, right? Okay. So once we've expanded this, we can take our imaginary parts of this equation, because that's what denotes to the sign, right? So let's take the imaginary part of this entire thing. Imaginary of cis. I'm just going to do cos theta. Okay. So, yeah, we'll write right-hand side here. Okay, so let's just take the imaginary part of all of this. So this is not imaginary, this is imaginary, this is not, this is. So we'll take 5 cos 4 theta sine theta I minus 10 cos 2, oops, cos squared theta sine cubed theta I, plus 5 sine 5 theta I. Obviously the eyes just disappeared because you've just taken the imaginary of them, but I was just showing you guys. And then so now we have to use trig. So we know that cos squared theta plus sine squared theta equals 1. And then so we know we've got a few causes here. So let's just do cos squared theta equals 1 minus sine squared theta. And then so we can use this equation, sub it into all of the causes, then you'll get all of the coefficients for everything.
Ollie,
Yeah,
why is it 5 sine 5 theta?
1 sine. That should be 1. I don't know why
Yeah.
I added a 5
Okay,
there.
thank God.
Yeah,
I
that's
thought I was
my bad,
tripping.
guys. That's my bad, guys. If I confuse any of you, that's
I
yeah,
think
so
everyone's confused.
yeah. So yeah, let's just sub it in. So we'll sub this equation into our causes here. So that will be equals 5 1 minus sine squared theta squared, right? Because it's cos to the power 4 sine theta minus 10 cos squared theta. Oh, sorry, this should be what? Oh, cos, no, 1 sine squared theta sine cubed. And then plus 5 sine 5 theta. All right. So once we do this, we'll expand this. So this will become 5 sine theta 1 minus 2 sine squared theta plus 4 sine, oh, no, just sine squared, sine to the cube theta minus,
Wait, did you put 5 sine 5 theta again, or am I tripping?
did I do that? Yeah, I did.
Shh.
Tripping. I'm actually tripping here. Yeah. Probably because my S's look like a 5. Anyways, so we have that. Let's expand all of this as well. So we get sine 3 cubed minus sine 5 plus 5 sine 5. Okay, so this is what we get. And then let's just expand everything out. So we get sine theta minus 2 sine cubed plus sine to the power 5 theta minus 10 sine 3 theta plus 10 sine 5 theta plus 5 sine theta. And then so everything basically just cancels out. And then you'll get your coefficients in front of your sines. So basically it will become sine theta minus 12 sine cubed theta. And then we've got a sine 5 here, another sine 5, and that should be a sine to the power 5, I believe. Yep. So we got 15, 20. Oh, no, not 20, 16. Okay, I think that's it. So the start of this question, our coefficients A, B, C,
You wrote
and
5
D.
sine theta again.
Fuck, why do I keep doing that? What do I keep doing that? I don't know why I'm doing that. What the hell am I doing? Okay, there we go. So I keep getting this wrong. No. There we go. That's much better. So we've got 10, 11, 12, right? Should be 12. There we go. Okay, so A equals 12, B equals negative 12, and C equals 1. Right. Okay. So that takes really long. Yeah, if you get this type of question,
I don't think the answers is right for that one, by the way.
and where have I gone wrong this time?
I feel like with your Pascal's triangle, you know how it's 1 and then 5? Shouldn't it be like 5 cos to the 4 sine theta?
Oh my God, did I miss 1, 5, 10,
Yeah,
10?
look, 5 cos to the 4 sine I. That 5 is still there. So you can make 1 minus sine squared, and then you square that, but you've got the 5 coefficient. Like if you go down. Like keep going, yes, or keep going down a bit. Yeah, you see that 1 minus sine squared all squared? Shouldn't there be a 5 there? Because that was originally 5 cos.
Here, are you talking about here?
Yeah.
Okay, and then where have I done? Oh my God, I've missed
So then you have
I've missed the
like
5 here, don't I?
yeah.
Ding bong, hiccup.
Alright.
So we basically need to adjust everything. Actually, it's not that bad. It's not that bad. Why does it keep going that? We just need to. Yeah, all we need to do is times 5 by everything, I'm pretty sure. So 5 would go here. This will become 10. 10 here. And there should be a 5 here as well. And then now we do the adding and subtracting. So this should be 5 here. And then so -10. So this should be 20, -20. Oh, just 20 here. And then to the power, that should be 20 as well, right? Am I tweaking? No, that should be 20. No, that should be, what am I saying? That should be 16. 16. So that should be right. Okay, so that's how you would do this question. Sorry guys for the enormous amount of mistakes in my writing, but we get through it. So 16, -20, and 5. Okay, if you do get this question, I would recommend leaving like the last maybe 20 minutes to do it. But if you know how to do it, it's pretty procedural because it's the same every time. It doesn't matter if it was sine to the 5 theta. It could be sine to the 3, do the same thing. Okay, why don't we move to vector calculus? Let's have a go at these. All right. So this is a multi-choice. It should be pretty easy, hopefully. Probably the only easy question here tonight. Oh yeah, also for vector calc, we won't go through projectile motion because I'm confident you guys know how to do projectile motion pretty well. Because yeah, it's just subbing in formulas, knowing how to solve for time, all of that stuff. You let position equal 0, whatever, stuff like that. So should be okay. All right, for this question, 5.1, we've got R of t in this form, right? So we want to parameterize this. The second question is tech active. So the second question is tech active. First question you shouldn't need tech for the first question. You can if you want to, but I wouldn't. Just try to use pen and paper tonight. A, yes, it's a straight line. I'll just quickly walk through it. So because this is the I component here, we'll let x equals cos squared 2t. And then y here is cos 4t, right? And so we want to make an equation that kind of does both of them. We also know that y here, we can use our whatchamacall, our identities. Let me just get the spec formula shit up. Where is it? someone finds the identity, can they just tell me what it is so I can just quickly write it down? Because I know
Cos squared of A equals 1 plus cos of
cos squared of
2A.
A equals what? 1 plus cos 2A?
Yeah, something like that, right?
Yeah, something like that. You'll get a yeah. So you'll get a straight line in the very end because you can sub y and x into a straight line. I will do it because if people don't get it, then I'll be a bit troubling. But
Over 2. Over 2.
over 2, there we go. All right.
Sorry, mate.
Thank you. Okay, so we know that we can see how this 4t here is, we can break it down as cos 2 times 2t. Right. And so when we do this, let's do 1 plus. So we'll factorize. So it should be 2 cos 2a equals let's just rearrange this to become this. And then so we can write this into this form right here. That's kind of the goal. And so we've got the 2, the cos will be 2, it will be cos squared 2t minus 1 with the 2 out the front, right? And then so these two equations are basically very similar, right? And we can just sub them in because we know y equals this, right? So let's just sub, because x equals cos squared 2t, we can just do y equals 2x minus 1, and it should be a straight line because we sub in x equals here, basically sub this right into here. So you should get a straight line there. All right, cool. Let's try this teardrop question.
Sorry, can you just scroll up a tiny bit?
Yeah.
Cheers, mate.
Good. All right. So let's just all right. So let's do the teardrop question. So a curve represented by this vector equation here with alpha, we don't know. Sorry, a equal is a element of all real numbers that are positive. An artist requiring number of teardrop shapes in the solid between x equals 0 and a about the x-axis. So from this statement, you know it's like a revolution question, right? But that's kind of at the end what we do. Determine if the volume has 8, if it's 8 centimeters cubed. Right? So determine the value of A. Okay. So why don't we do, we'll do the same type of strategy we used here by letting X be the I component and Y be the J, right? So X equals A cos theta, right? Oops. And then we also know Y equals sine 2 theta, right? And then so we can use our trig identity. I think from memory it's the 2 sine theta cos theta. Can someone check that for me?
Yeah, that's the one.
Yeah, okay. And then so we can see how our cos, well, our cos kind of appears again in the y equation. So we can make this we can square both of these. So we can get an equation. So a squared cos squared theta. And then that equals a squared 1 minus sine squared theta. Right. And then so therefore cos squared theta equals x squared over a squared. And then sine squared theta equals 1 minus x squared over a squared. Whoops. Right. And then so we can substitute into when we make this y squared. So here y squared is 4 sine squared theta cos squared theta. And then we can substitute these two, right, into here. And so we get an equation of y and of y's and x's, right? Because that's what we're trying to do. So y squared would equal 4x squared over a squared 1 minus x squared over a squared. Okay. So after this, we've got our equation in terms of y's and x's. Then we're finding volume of revolution, right? So we want to basically do that. So obviously y equals this. And then volume revolution, we know that v equals 0a pi dy. Oh, dx pi y squared dot dx, right? And then so we can just sub in our original equation, 0, and it was 8 centimeters cubed, 4x squared, a squared, 1 minus x squared over a squared. I forgot the squared there.
Are we integrating this with respect to x or y?
The respect to x, right? Because y is the function, right? Y is the function you're integrating in respect to x.
Yeah, okay.
Because remember also our it's revolved around about the x-axis as well. So yeah, I don't expect you to integrate this by hand because that's kind of mean. So we'll just say use calculator and you'll find A. So I don't know what calculator you guys have. I have I think the TI-84. So there's something called solver from memory, I'm pretty sure. Somewhere it should be. Yeah. Yes, use numeric solver on the TI-84, sub in your things. And you should get your A value as 4.77. Okay. So yeah. Yeah, so that's how you would do this question here. Oh.
Hey, how do you do it on the TI-84?
So basically, can everybody see my calculator? It's got a crack in it, but you go on math, which is on the very left side here, and then you go all the way down to the very bottom, and then you'll see like C here, numeric solver, right?
Oh, true.
Yeah. And then you put that in. Equation 1 would be your integral equation, right? So you'll do a definite integral, put it in there, put A's as well. And then equation 2, you would be like, oh, alpha A equals, well, just equals 4. Like equation 2 would be just 4, and then they'll solve it. Oh, you can put it, yeah, so
Okay.
that's how you would do it. Yeah, okay. All right, let's go to the next one because that's just how you would try and attempt this question. We've got some integration by parts. I'm sure you guys know how to do this by now. It's just some general ones. Obviously, for the this, it's kind of just recognizing when to use integration by parts. So something like an exponential with a composite function of exponential and trig, right? We'll know how that you have to do integration by parts twice for this, okay? And then log x, this should be ln x, but this is ln x. Whoops. Right, so for this one, you let u equals ln x. du is 1 over x. And then v is 1 dv equals x, okay? And then once you do that, you sub it into the equation u dv v du. And then you solve that. So these are pretty common integrals that you might get for by parts. I won't go through them because I'm just assuming, guys, you know how to do this. Just integrate by parts twice.
Can you explain like the key, I guess, strategy to solve these cyclic ones?
Literally do it by do it twice. Yes, dv is supposed to be 1 here. Whoever called that out. Yeah. So basically you would get it once and you realize, okay, I've got to integrate like e3x again, sine cos to it would be cos 2x that time. And then you integrate again, and then so you get e3 to the x, some coefficients, and then minus sine x. And then after when you get that integral, you can drag the minus sine x or e to the x sine x onto the left side. So, and then you get the equation. So, I mean, we can walk through it. Let's just walk through it so it's kind of clear for everyone. So, let's let either one works. You can let u equals e to the 3x or dv equals sine 2x. Doesn't really matter. But for this case, I'm gonna let's let u equals sine 2x du 2 cos 2x, right? And then dv is e3x, v is 1 over third e to the 3x. So we know u dv equals uv minus v du. uv is 1 over third sine 2x e to the 3x minus v du, 1 over 3 e to the 3x. Du, 2 cos. So we'll make this 2 cos 2x here, right? So then we need to do it again, right? So you can let different letters. I usually do the same because I'm pretty lazy. We can also take the coefficient out as well. So it makes our lives easier. So let's just see, the one rule for this one is if you let the trigonometric function be u, the next time when you do it, you got to follow the same, right? You can't change it up and be that, or else you're just going to reverse it back, right? You're going to reverse it back into this basically. Let's do that. So we'll let cos 2x again. And then this should be negative sine 2x. And then dv is e to the 3x. V is e 1 over third e to the 3x. It's out of page. And then so we get 1 over 3 sine 2x e to the 3x minus 2 over 3. Let's put big brackets here. So for this part, follows the same rule, right? uv minus v du. Okay, integral of v du. So we'll drag this part into this big brackets here. So UV is cos 2x. V is 1/3 minus integral of V 1/3 3x. And then du is -2 sine. So we're going to put -2 here, sine 2x, right? So what can you see about this? This one here is the same as here, right? So, well, this becomes a positive. Let's just make this a positive. So +2. And then what happens is you literally, well, we've got also the 2 here because that's our coefficient that we've gotten now. So why don't we expand this? Let's just write the whole thing. So e to the 3x sine 2x dx equals 1/3 sine 2x e to the 3x minus 2/9 cos 2x e to the 3x plus the integral of 4/9 e 3x sine 2x dot dx, right? So after this, we can just minus
sorry,
the
one second. Where did the 219 and 419 come from? Did you like square it or something?
Just from expanding the brackets, mate, with the coefficient.
the coefficients here.
I think might be tweaking which brackets.
There's these big.
Ah, are those brackets? Oh, okay.
Yeah, sorry, that's my bad. So yeah, 2/3, and then so now we can just put it like minus it. So because this is like basically 1 in front of the integral, we can do 1 minus 4/9, which is just 5/9, right? So the integral, well, wait, no, we're not going to do that. Let's just, yeah, no, that's what we're going to do. So we get what's it called? 5/9. One over 3 sine 2x e to the 3x minus 2/9 cos 2x e to the 3x, right? But there's a coefficient there, so we'll divide through. So therefore, e to the 3x is equal to 9/5 1/3 sine 2x e to the 3x minus 2/9 cos 2x e to the 3x. And plus c, right? Don't forget your plus c's. So yeah, that's how you do that. This one, it's pretty standard. I'm sure everybody knows and seen it before, so I won't go through that one. But yeah, that's how you would do this repetitive trig exponential type of integral that you might get. Okay, let's move on. So yeah, we've also got trig functions to integrate. Here are some rules that you should know on what technique to use in the exam. So if it's a if for example here, if the sine or the cos is negative, sorry, not negative, odd, right? You use a u sub. So you would do let u equals like cos to the squared x, right? I can show you how to step this. So why don't we do that?
Sorry, mate. I know that you've just started the next question, but can you just scroll up so I can just copy down the other question that you just glossed over?
Yeah. Sorry, if I'm going too fast, just let me know, because yeah.
Ollie, I have a
Alright.
question.
Thank you, mate. Thank you.
Actually, I'll ask you after.
All right. Okay then. So yeah, here's some common rules. So why don't we do both of these integrals? so let's start. Okay, so when it's odd, so this is like M, right, and N. If one of these are odd, you'll use a U substitution rule. And if they're both even, so for example, if this one was like 4, right? Don't do that. Use double angle formula. Okay. So that's, I guess, a trick to know. So this one we would use a double angle formula. Why don't we go through and try and attempt this? So okay, so we can rewrite this as integral sine to the power of 6x cos 3x, or cos 2x, and then another cos x, right? So what we've just done is taken one of the cos x out, right? And then so we can see here, we can, we know the identity cos squared x equals 1 over sine squared x, right? And then so we can sub that in to our integral dot dx. 1 over sine squared x to the power of 2. Wait, no, we don't need that. Just that. That's fine. Okay. And then cos x, obviously. I'm going to give myself a bit more space. Okay. Cool. All right. Now we can U sub it, right? Because we've got sine terms and we've got a cos term. So why don't we let U equals sine x? And then du is cos x. So we can, this will be u to the 6, 1 minus u to the 2, cos x. And then this would be, sorry, yeah, dot du over cos x, right? And then so you can see that the cos x nicely just cancels out. And then you've got a really easy, why is that bad? That shouldn't be that. 6 minus u to the 8 dot du, right? And so we then get u to the 7 over 7 minus u to the 8, 9 over 9. Let's see. And then let's just sub in our sine again. So we get sine to the 7x divided by 7 minus sine to the 9x divided by 9 plus c. All right. So that's how you would do that. All right, next question. Let's do the definite integral of cos 2 7x. Like I said, you would use double angle formula for this. If I like added a sine to the x, you'll see that using 7x. Use double angle formula, right? Still, it will pretty much do this really nicely. I'm sure we don't need to go through that. Is everybody happy with kind of trig subs? I'll leave the answer up for a bit. And then I'll when I upload the so if sine to the 7, you would still, yeah, so any odd power you would use a U sub with trig. And then if they're both even, only if they're both even, we'll do what's it called? Double angle formula. So that's kind of the general gist there. All right, cool. Yep. Okay. Let's go to the next one if everybody's happy with that. Partial fractions. So this is a table that's really nice that you should probably know. It just tells you how you would do the expansion given these denominators here, right? So we know if it's a polynomial at the bottom, we would do ax plus b. Yeah, so I'll be uploading, well, I'll send this recording to Ollie, and then he'll probably upload this. So yeah. Okay. Why don't we try partial fracts? Right. Okay, do you guys want a bit of time for this one, or do you want me to just get straight into it?
How far through are we, by the way?
We've got a few more.
Okay. All right.
Like it's honestly like this
Sure.
one, we don't have
Bit of a
to
halfway.
do this one because this one's just literally doing a definite integral of an inverse trig, right? So yeah, up to you guys. Because I can
Okay,
just
maybe from now on, if yeah, we could either skip or if we just like
just let
start
me know
start
what
straight
we
away.
want to do, because I'm happy just to like skip if you guys understand it. There's no point of me doing it, especially when it's the night before the
Mm.
exam, right? Because you guys should probably be in bed by 10 and just have a good sleep before tomorrow.
No,
Don't
exams are at midday, bros.
Yeah,
Yeah.
but like just don't do don't do a full
What is
exam
sleep?
tomorrow. That would probably like make you really tired for your exam. So
I mean, maybe if you just start the like solving straight away, we can just work alongside
work
you.
alongside. Okay.
Yeah.
All right. Why don't we do that then? So okay. For this integral, we've got partial fractions. Like it should be pretty obvious to use what technique at this point, what technique to use given an integral, right? So if you see literally factors on the fraction, just use partial fracts. So we can decompose this by doing that. And so because x squared is twice, from our rule here, right, if a equals 0 here, that's still going to be the same. And so we've got this a1, a2, and we have to include both of them. So what I mean is we'll have a over x, right, plus b over x squared. And then we've got an x plus 2, so c over x plus 2. All right, and then we multiply all of this to this side. So we'll get 4 equals a x plus 2 plus b x plus 2 plus c x squared, right? Okay, so what do we do now? Well, we can we've got a system of equations, and so for the x squared component, oh, let's just expand it first. Why not? Let's expand. Okay, so for the x squared component, we have a plus c equals 0. For the x component, we have just, oh, there should be an x here. There should be 2a plus b equals 0, right? Because this other side here doesn't have any x squares or x other thing. And then for the one component, so number, we have 2b equals 4, right? So then we can just solve this. So b equals 2, right? And then we can solve for a. So 2a plus 2 equals 0. Therefore, a equals -1. And then -1 plus c equals 0. Therefore, c equals 1. And so we can rewrite this entire integral, right? We can rewrite 4 over x squared plus x plus 2 plus dx equals -1 over x plus, well, let's just write integrals in front of those, dot dx plus integral of b is 2 over x squared dot dx plus c is 1. X plus
Sorry,
2.
with the
Yep. With
with the x squared, right? Why can't we do bx plus c over x squared?
right, because when you look at this, it's basically saying that it's like a perfect square, right? Because x squared is basically, if we kind of look at it, it's just x plus 0 squared, right? In terms of this is when you have something that's not a perfect square, right? So anything like x squared plus, let me just try not to make this a perfect square, plus 1, you can't factorize it and get it into like an x minus a squared or x plus a kind of structure, right? I don't think so.
Okay.
So that's why we do the we don't use the bx plus ax plus b here in this example, right? So only if you know that this denominator can't be factorized into like a perfect square kind of thing, then use this here, right? Use the ax plus b. Okay, so we can do the integral of this. This will just get us negative log x plus 2x -1. So this will become a negative. And then plus ln x plus 2 plus c, right? Something like that should work. Okay, does that make sense for everyone?
I just got a quick question. When it's x squared plus bx plus c, would the ax plus b still be put into play if there was no c value? So if it was just x squared plus bx?
Well, if there was no c, you can factorize it like x plus b, right?
Oh
So
yeah. Yeah. Yeah, you make a good point. Never mind.
so this is kind of the thing to remember when to do partial fractions. I don't know if your teacher's shown you this table, but like, yeah, it's pretty helpful.
Nah.
No? Yeah. Okay. So that's, so you guys can basically do any partial fracs they throw you now. So yeah, that's just some rules to know. Yeah, pretty happy with this. Is everybody happy from
Wait, just pause for like half a second.
take a picture? Okay, yeah.
Quick question. Do you reckon there's any chance that last form could show up on the exam?
No way. QCAA isn't that mean. I think
Thank
hopefully.
God. Okay.
I don't reckon they'll give you that. So this is highly unlikely, but definitely these can definitely pop up. Okay. All right, let's move on. Inverse trig. So it's on the formula sheet. Just know when to use it. In this case, this one's actually kind of a hard example because you've got to split these two components, right? It kind of looks like you can do a u sub, like a let u equals this, but you kind of notice that where we've got like, we can make these squares, right? So this is 5 squared, this is 3 squared, right? So when you kind of see that, don't do the u sub. So let's just separate these two. So if we want to find the integral of these, right, we can separate them. Dot dx equals. And then so let's just go 3x minus 225 minus x squared minus 5. Okay. So we've got two separate integrals basically. Then I'm just gonna do that. And so one of them, the left-hand side one, is gonna be a u sub, right? You can just let u equals that. So that can cancels out 3x. You get something nice. This one obviously looks like a trig. So with this, you can use arc sine, inverse, or arc cos. So inverse sine or inverse cos, because one's just the negative of the other. It doesn't really matter, right? So yeah. Okay, let's do this very quickly. So left hand, so this one would be let u equal 25 minus x squared, right? Du negative 18x. And then we can rewrite this as 3x u to the half, right? Dot du divided by 18x. So obviously these x's cancel. You get 1 over negative 6 at the front. Okay. Dot du. Okay. Let's just, we know how to do this, right? So that should be fine. This side, arc sine, arc cos, arc sine, either way works. So what we can do is we can, let's just factorize things out. So 5 on, let's first get the 5 out. And then we can also factorize the root 9. So the 9 here. So what we can do, well, why don't we let's do it this way. Let's let v equals 9x, 9 squared, v squared, right? V squared equals 9 squared, x squared. V equals 3x, and then dv dx is just 3, right? Okay, so now let's just sub it in. X squared. And then now 3 comes out the front. And then so we've basically got two integrals that are very nicely done now. So we can, obviously this will become arc cos because it's just negative. So yeah, basically we can, let's just finish this. So this integral becomes 5/3, positive 5/3, because arc cos inverse v, v over 5, sorry, plus c. And we know v is 3x, right? So we'll just sub in 3x. And then for this one, we've got, well, it's going to be negative 1/6, 2. And that should be a positive. Yes, because this is a negative here. Sorry, guys. Because it's 1 over u to the power of a half. So this should be a positive, or plus 1. And then so there should be a plus here. And then in the end, you get 1/3, I believe. And then our u initially was this gigantic thing. So 225 minus 9x squared plus 5/3 cos inverse 3x over 5 plus c. Okay. It also wants to state the value of b, right? The domain of this function. it probably won't get you to do that, but if you want, just look at, because this is an oscillating part, so we don't really well, we do care about it because it gives us our height. And then but this is the should focus on the domain because we can't. Yes, whoever said 5/3. Yes, you're right. Yep. So that's how you would.
So I've got a question. With that second part where you split it into 3x over that and 5 over the other half, how come we can't use tan, inverse tan for the 5 over root 25? Because isn't 25 just 5 squared?
Because it's got a square root over it. We can only use tan if it doesn't have a square root. If it was like that, you can, I think you can use tan, right? So
Yep.
because it's got a square root over it, think sine and cos. And then if it doesn't, then right, just go straight to tan. So yeah. Okay. Let's just finish with that because I'm pretty sure you're sick of integrals. This is another integral. So yeah, if you guys want to take a photo, maybe do it later.
How long do you reckon it will take for this to be uploaded, by the way?
I don't know. It depends when Ollie decides to upload it. So I'll send it to him right after and then probably upload it to him. He'll probably upload it. So yeah. Okay, so obviously find the distance for the first 3 seconds. We just know we need to integrate between 0 and 3, right? And this function, because this is the velocity function, right? I'm just going to say v of t dot dt, right? Which is the integral of 0 to 3, 9 over 81 minus 4t squared dot dt, yeah? So for this, what would you guys use? Would you use inverse trig here, or would you use some other technique? Yes, partial fractions is right, because this is a difference between two squares, right? So you can see how this 81 minus 4t squared, we can well decompose that into a over 9 plus 2t, and then plus b over 9 minus 2t, right? So yeah, we just do the integral of that. You'll get logs and stuff, natural logs. So that should be fine, right? Okay, let's go to implicit differentiation. So if it's a difference of is that P? I don't know what PS stands for. I'm assuming partial perfect squares. Okay, we know to use partial. Difference of perfect. Yes, right. So if it's kind of in this form, difference of two squares, then yes, you would use partial fracs, because a lot of people get tricked by doing inverse tan and it just doesn't work. Okay. Let's try implicit differentiation. This should be fine.
ODEs mean what? Overdoses?
Pardon?
What is an
Wait.
ODE?
Oh, first or ordinary differential equations. So that's what you guys are doing. So like anything like dy dx like that, this stuff is all ODEs. That's what we call them in uni. So sorry, if that's kind of confusing. Yeah. Okay, let's go to this implicit differentiation. So this is a product rule here. This you can just derive normally. This becomes 0, right? So let's just do this product rule. So let u equals x squared. Well, du will be just 2x, right? Because what we're doing with this when we do dy dx is we're basically doing d dx of x squared y cubed plus d dx of sine y. D dx of 4, right? So let's just consider this first part. Ux squared, du is 2x, and then we let v equals y cubed, and then so dv dx, right, is equal to 3 dy dx y squared, right? So, and then obviously here, this just becomes dy dx cos x. And then this becomes 0, right? So, and then, oh, cos y. That's my bad. And then we can use our product rule. So u dash v plus v dash u, which is 2x y cubed plus 3 dy dx y squared. U is x squared here. Plus dy dx cos y equals 0. Okay, so now that we've got this, we want to put everything that doesn't have a dy term multiplied to it on the other side, and then factorize the dy dx out. So dy dx 3y squared x squared plus cos y. And then so that's equal to negative 2xy cubed. And then obviously we just divide everything by that, and then you get your dy dx, right? So then dy dx equals negative xy cubed divided by 3y squared x squared plus cos y. Okay. I did do cos y, right? This is all cos y. Yeah. Okay. All right. Let's go. Is everybody okay with this one? Yeah. Okay. It was easy. All right. Let's try this one. Let me move this. Okay. So let's have a go at this.
Hey, sorry, for the find the antiderivative question. So if you can just scroll up just for a second. When you you know how you put the minus on the outside
Yes.
for the second part, so that's the minus 5/3 integral of
Yeah.
that. Do you make, so does it integrate to arc cos or arc sine?
Well, I kind of just like, I think it's on the formula sheet, right? If it's negative,
Yeah.
let me
Oh
have a
yeah, if it is negative, it does become arc cos.
yeah. So I've just taken it out. I don't know. Sorry, it's a bit confusing. So yeah. Honestly, because if you didn't, so this is positive cos inverse, right?
Yeah.
You could also do it as negative sine
Oh,
inverse,
okay. All
and
right,
that would be the
I get
same
it.
thing. Would be this
Yeah.
exactly the same thing. So yeah, any one of them works, right? So if you get an inverse cos or an inverse sine, you could do whichever one you want. Just make sure to remember the, I guess, the sign outside of the integral.
All right. Cheers, mate.
Okay. Particle moving after 2 seconds when the speed is this and displacement is that, and it's given by this function. So yeah. So whenever, I guess, it's in the in a structure where the function of velocity is in terms of distance, you should be thinking about the A equals dv dx times dx dt, right? So what we can do is if we derive across, so what we do is v of x v squared minus 9x. If we let's just derive this. Okay. So this derivative, when we do it in terms of x, will be dv dx. And then obviously we get a half. And it's sorry. That's wrong. That's so wrong. It should be a half v squared like that. Because we know that acceleration, right, is equal to dv dx times dx dt, right? And velocity is dx dt. So when we do this, this should be acceleration. Oops. Yeah. And so we would get the half outside here as well. Does that kind of make sense to people? I'm pretty sure that was so confusing. I'm pretty sure I explained that in the most confusing way. No, not really. Okay, let me explain that from the start. All right, let me do this from the start. Okay, so our function is this, right? To compute the acceleration function, we do we derive it in terms of in respect with x. Okay. All right. So for example, yeah. So basically what's Jeff said, I think that's like a good explanation. Sort of for this question, I'm not thinking. Okay. So okay, so we know that acceleration is given by dv dx times by dx dt, right? Obviously, when these two terms cancel out, you get the acceleration function. Okay, in this case, we've got what we've done is we've basically taken the v out and made it here because we can do that. And then so you've got this function dx dt. Well, dx dt is also this velocity function because that's how you do it. So if we wanted to compute this, it would become what's above here. And so that would be ddx 63 minus 54 minus 9x, right? And 9x squared. And then so you get, when you derive this, you get half of negative 54 minus 18x. And then so what you get, because this is acceleration here, this equation here is the same as acceleration, right? Because I'm pretty sure it's also in your formula sheet, right? Where they've given it to you, right? So d of dx is half of this thing is in your formula sheet. So we can derive this, and that will become our v squared is this component here, right? Our half is just factored out, and so we can derive this, and that will give us acceleration. Does that make sense now? Sort of, maybe. Okay, cool. We've got 4 questions left. The 2 stats ones are quite short. So, yeah. Okay, once we do that, we know that then acceleration is equal to this right here. So, okay. So it's in the form, we know acceleration, we can write this as x double dot, right? And that's equal to 9x plus 3. Now, this kind of looks like, this is in the form of simple harmonics, right? Because we know simple harmonics, our acceleration is equal to, what is it, negative w squared of x, right? But this is x plus 3. So all we need to do is factorize that out. So it would be x minus 3 type of stuff, right? And w is obviously 3. Yeah. Okay, cool. And then yeah, prove that it's simple harmonics. So we can see clearly from this that it's simple harmonics. So you just need to write that it's in this form, right? Because that's a simple harmonic form. And then period is 2 pi over omega. And so your period is 2 pi on 3. Why did the x plus 3 change to the x minus 3? Because we've got the minus out here, right? Sorry, I've made a mistake. No, so yeah, the minus is out here because that's the form of v squared is w squared a squared minus x squared. Is it? I don't think so. Let me have a look. That's square. So when you square root everything, but no, that's velocity you have there for simple harmonics. That's your velocity equation. Acceleration is this kind of form right here. So wasn't the minus already out? The minus here, because we no, you're right. You're right. Yeah. Should be plus. Okay. anyways, so from this we can yeah, so the period, like I said, 2 pi on 3, because our omega is 3 after doing root 9. And then so we can also do yeah, okay, part B is if initially the particle at point x equals 1, express it in terms of t. So what we can do is
Wait,
how do you find it?
Oliver, how do you find amplitude in the center?
Oh, okay, let me go through that. So we can we know that V equals -63 minus 54 minus 9x squared, which is equal to negative 9x squared plus 6x plus 7, which we can factor out. X plus 7, x minus 1. So when v equals 0, so it would be x equals 7 and 1, right? Because they oscillate between, because remember in simple harmonics, our thing just oscillates between two things, right? Because it's a trig function. So in this case, our amplitude, because it oscillates between -7, we also need to find the center of motion, which is the equilibrium point, right? Because simple harmonics kind of looks like this sine wave. We've got a equilibrium point here, and then it just goes up and down. So how do we find the equilibrium point? Well, this yeah. So this part here would signify your equilibrium point, because if you expand this, if you expand acceleration, what you get is I'll do it here. 9x plus 27. But the plus here is just, yeah, it's just -3, because that's where it oscillates between, right? And it's just also, yeah. So center of motion or equilibrium point, x equals -3. So our amplitude is 4, right? Because it goes between those two. Okay. Honestly, I'm not going to do the second one because it's just a cos function. You just sub it back into your simple harmonic motion function. So I'm gonna go down and do the growth one. Yeah, the first order ODE with the logistic function here. So yeah. All right, first one's just proving that this, when we get this formula, this population formula, and then from this differential equation. Right. So do you guys want to have a go, or should I just get straight into it? Looking at time, probably get straight into it. So we know that I'm gonna need actually a lot of space. So let's verify this by substitution. So we know that n is given as 2000 over 1 plus 9e to the negative kt. So we can rewrite this as 2000 1 plus 9e negative to the negative 1, right? So then dn dt, let's just derive this, right? We're just deriving this. So it would be 2000 times by 9e negative kt, right? 1 plus 9e negative kt, negative 2 here, right? Because we've just done a chain rule, basically. So this becomes 2000 times 9 ke negative kt divided by 1 plus 9 e kt squared. Okay, cool. We know that from our original substitution that this 2000 times is equal to n.
Wouldn't it be negative 2000?
Where at? Because
Negative k?
negative k here, when we times by that, we've also got the, when we do the chain rule,
Yeah,
this,
for the outside of the chain rule, that one.
this negative becomes here. This negative also comes here. So negative times negative is positive.
Oh, okay, cool.
Yeah, because we've got we take the derivative of the inside as well and multiply it. So that's a negative as well. Okay. And then we know that 1 plus 9e negative kt equals 2000 over n. That's just rearranging from the initial substitution, right? So that's that. And then so we can rearrange it as 9e, whoops, 9e minus kt equals 2000 over n minus 1, right? We're just putting the 1 to the other side. And then so that actually becomes 2000 over n. Oh, yes, 2000 minus n over n, right? Because if we make this 1 and divide by n, that just becomes one function. So, yeah. All right. So, okay, let's go to our next one. So we know that from our original dn dt equals 2000 times 9 e to the, 9k, sorry, e to the negative kt. And then we've got our 1 plus 9 negative kt squared. And then so we can sub in, we can actually factor this out. So it will become k. And then we've got 2000 over 1 plus 9e to the negative kt squared. And then times 9e negative kt divided by 2000. So yeah, this kind of goes into that. Because we factorize the k out from here, and then and then we take out this to become this 9e to the negative kt to be on the other side. So yeah. All right, cool. And then let's keep going. This becomes k, because this function we've derived from here is here, right? So this becomes n squared, right? This becomes n squared over 2000. And then this part here, 9e to the negative kt, we can see that this becomes that, right? So that would be 2000 minus n over n. And then so therefore dn over dt equals k n 1 minus n over 2000. All right, cool. So that's how you would prove that. Question 2, find the initial number and limiting type of bacterial cells that could eventually be present. So part B is, well, initial number is just when t equals 0, right? So when time equals 0, that's our initial number of bacteria present. We just sub it into our equation that they've given us here, right? And you should get just 200 because, okay. And then, right? And then since, ooh, did I make a mistake for this one? Oh yeah, and then limiting type. So limiting type, we have to take the limit. So since k is greater than 0, if we take the limit as t approaches infinity n of t, right? That would just be 2000. Because we just assume that in this function here, t is really, really big. E to the negative basically infinity is just going to be 0, right? So this part becomes 0, and then so you just get 2000 divided by 1. So yeah. Initial equals 1000. If I sub in t equals 0 here, t equals 0 right here, e to the 0 is 1. 1. So 1 plus 9 is 10. 2000 divided by 10 is 200. Okay, let's continue.
Sorry, are you able to just zoom out just for the working out? That's all.
Yeah.
I just want to
Get that
screenshot it.
screenshot, Jeff.
Cheers, mate.
No, all good. Okay, last question of this. It is observed that 1000 bacteria are present after 10 determine the value of k. So we're just subbing in here, right? So we know that n of 10 is 2000. So, 1000, sorry. So 1000 equals 200, 2000 divided by 1 plus 9 e to the negative 10k, right? Let's get that out so we can get 1000 plus 9000 e to the negative 10k, which is 2000, equal to 2000, right? Because we've just moved that to the other side. And then e to the negative 10k, oops, equals 1000 divided by 9000, which is just 1 over 9. And then so therefore e to the positive 10k is 9 over 1, right? Which is just 9, because we've just flipped both sides here. And then let's just do a log. So log e of 9 equals 10k, therefore k equals ln 9 over 10. Right? Okay. All good. Let's not do this one. This is fine. Okay, we're up to stats now. Are we okay with this question first? It's just subbing in. Yep, okay.
Sorry, with
What-
that proofing question, what would you like recommend as a general approach to those types of questions?
This one.
That
This
part A,
proof,
yeah.
yeah,
Yeah.
you've got it because it says by substitution. You have to assume that you're subbing in n again. Look, there's no really right way to do it, but hopefully they won't give something as hard as this because this one's pretty hard. But yeah, just have a crack at it because honestly, I couldn't tell like what way to to approach this question if like you haven't seen it before. Yeah. Anyways, let's go to stats, our final unit. Stats is pretty chill for you guys, right? Because everybody does methods, so it's basically an extension. So just some general stuff is like when we have the distribution x and we've got a mu squared, right? What estimates this is the sample mean, right? The sample mean estimates what mu could be, and then our standard error estimates for what well, in this case, the variance here. This is what estimates this variance, but obviously our standard deviation is this. And so this is our standard error, and our standard error or sample standard deviation is s divided by root n, right? So that's just your general stuff, X is your distribution, distribution of X. So it's just could be anything. Distribution of heights, distribution of ATARs, could be anything, IQ, stuff like that. I'm telling you this now because I'm thinking they might shoot you a multi-choice and be like, oh, what represents, X bar or something like that. So it's just good to know the variables, what they mean, right? So capital things, just like, I guess, to need to know capital letters in statistics represents distributions, right? So you could have a distribution of X bar, and that would be the distribution of all of these sample means, right? So yeah, that's just general stuff. Let's go to some stats. Okay. All right. So, okay. Let's do the stats question. So we're giving a 90% confidence interval. Right. And we can easily find the sample mean, right? Because they've given you a sample from this confidence interval, right? So the sample mean is just when we add the two here and divide by 2, right? Because the middle of these two numbers is always going to be the sample mean. And so that gives you 416.5. So yeah, then we also know that it's a 90% confidence interval. So the Z score of 90% is 1.645, right? And then so we can calculate the margin of error, right? Margin of error equals 1.645 times your standard error, right? S over root n, your sample standard deviation divided by square root of n. And then so our margin of error is going to be just our sample mean, right? 416.5 minus 390, which is what we want to know, right? We want to know if it includes, like, what's the lowest confidence interval we can include, right? And our S over root n, well, we know that as to be, 416.5 minus 397 equals Z 90 times square root of root n. And so therefore, square root of root n is 19.5 divided by 1.645. Okay. And so we can apply this right here. Minus 390 equals 1.645 times 19 No, we're trying to find the Z score, sorry. We're trying to find the Z score. That would include 390. So Z of X, 1.645. And then, so our Z score in the end is going to be, when you just do the math for this, 6.5 equals Z of X equals 2.235. Okay, cool. Yeah, and then so we would use calculator for this to find the Z score. It should be a 97.46 confidence interval. Okay. This here is just doing a 95% confidence interval. So I'm sure everybody can do that. Would you like me to go through it, or it's just like you guys are all right? Can you just do the show for the one you can do? Yep. So first step is we find the mean, sample mean, right? Because that's what's they're estimating. And then we find the standard error, right? S over root n, because we can do just the margin of error equals Z of 90 times S over root n. And so we know this Z of 90 is 90%, Z score is 1.645, right? And over here, this difference gets us 19.5. And then, so our standard error is this. And then MOE is 1.645 that. And then so we can, to include our 390, right? Because that's going to be the very edge of this, because we want to find the confidence interval that includes 390. And so we just sub it back in and then find our Z scores. And then that should be it. Right. Okay.
Sorry, quick question. The margin of error is the same as S over root n, right?
Yeah. No, margin of error, the formula is Z, whatever your Z score is, right, times by S over root n, right? Because the margin of error is, let me draw a normal distribution. That's crap. But anyways, your margin of error is, let's say you estimated the mean, or in this case, you've estimated that the mean is, what is it, 416? Right? And so what your and then you've given a value. So margin of error here is, sorry, not margin of error. The lowest value is here. Your margin of error is this distance, right? So that's your MOE. And then, so yeah, that's how you do this question. Because your MOE is the difference between 416.5 and 397. And so that's equal to your Z of X times S over root n. It's in your formula book, I'm pretty sure, because if you go to your specialist formula book, it's got approximate confidence interval of U.
The margin of error is just the one that's not given.
Oh, they don't give you margin. Yeah. So yeah, the margin of error, if you think about it, is just this distance here, right? This is also the same. So if I have an MOE here, this MOE is the same, right? And the distance is the same. So 436. If I do 436 minus 16.5, I get 19.5 as well. So that's why it's my margin of error, right?
You can also just remember that the margin of error, you can just replace it with X bar and make it equal that, and it's the same thing.
Yeah,
So
you can rearrange, like for your approximate confidence interval of mu, you can rearrange and do it. So yeah, skip. Okay, let's do this. This one's the last one anyway. So Yeah, this is the last one. What ATAR did I get? I got a 99.6. Okay. Anyways, let's do this. So we're given a confidence interval, right, and the values of X bar and stuff. And then find the value of n. So we want to find the value, the number, right? The number in the sample. And so Jared, one student at the school, has an IQ of 130, and Ashley said this is not possible because it doesn't lie. A comment on the reasonableness of Ashley's.
Ollie,
Yeah.
it is supposed to be 95.8, correct? Not 95,8.
Yes.
Okay.
Yeah. 0.8 there. Okay, so we're given a confidence interval, and we know our confidence interval is plus or minus z times square root of n. And this part is our margin of error, right? Because when we do our confidence interval, that's what we're plus or minusing. And then so that's equal to our 95.8, 104.2, okay? And so we can calculate X bar pretty simply, just doing the reversing this formula. So 104 104.2 minus plus 95.8 divided by 2. That'll give us 103. Okay. So we know that mu is 100, but our sample mean is 103. Our population standard deviation is 15, right? Now we use so we know that if n is greater than 30, we can use this.
Sorry, is it 103? How'd you get 103?
Should be 100, no?
No, so 103, these, when we add these two together, do we get?
You get 200.
I thought you had to minus.
95. Oh no, you something's not right. What? Yeah, no, it should be 100. That's our estimate. Yeah, no, that's 100. Anyways, okay, we know that if n is greater than 30, we can assume that the sample standard deviation is equal to the population because of central limit theorem, right? If we get a really big sample, everything becomes a normal distribution. That's kind of what the central limit theorem says. And then so we know that z equals s over root n, which equals 49. Oh, sorry, z times, why am I doing equal? Z times s over root n, which is also your margin of error, is 49 over 25 times 15 over root n. And so that's equal to 4.2, right? Which is equal to that. Well, we just did the math for that, equal to 4.2. And then so we can find root n by reorganizing everything. And so you should get n equals 49 as your answer. Pretty sure. So yeah, and then we've got a statement afterwards because that's what you need to do. You need to comment reasonableness. So from this, Ashley hasn't gotten it quite right? So Jared can definitely get an IQ of 130, right? But it doesn't have to lie within the confidence interval. And so yeah, that's basically what you write as a comment to that. So yeah. All right, that finishes the masterclass. I hope you guys enjoyed. It was very long and probably a lot. Best of luck with your specialist exam tomorrow. Hopefully they don't give you really, really hard questions.
Any of these questions?
Probably not. If they give you one of these, I'll be very surprised. But yeah, best of luck. I'm sure you guys will all do fine, especially when scaling is quite well. You know, would the exams be harder than these questions?
Half of these questions were taken directly from 2020
Um,
QCEE.
yeah, some of them were taken from 2020, some of them, yeah. So yeah, because 2020 is probably the hardest exam out of all of them because that was their first year trying ATOF in Queensland and they decided to make it really hard then. But yeah, you guys are the last year, right? Or before they changed the syllabus, or 25 is the last year. I'm not too sure. But yeah. Apparently they're making the syllabus harder. So
Have you seen the new formula sheet?
no, I
Syllabus is ass.
what is it?
Bro, the
Is
new
it the
formula
same
sheet
thing
is
or is it like
crazy.
I haven't seen it because probably should see it because I'm tutoring a few students, but anyways, hopefully it's not too hard. Like
It's like 8 pages now, I think.
the last two questions. Can you go to the last two? Okay, let's go to that. There we go. Here are two stats. Yeah, so some stuff that my mates and I did during the exam is like one of the really sweaty kids in our grade like used fingernails to circle multi-choice during perusal. So that's a strat you could do during the tech free, which is pretty funny. So yeah, that's a strat you could do. Yeah, fingernails. So like, yeah, it's really sharp. Make a dent in it. I didn't do it because it wasn't that difficult. I recommend in that time you should like actually read through the entire paper so you can plan on what's worth doing and what's not. Like what can you do the quickest and correct, like most accurate, and what can't you? So and then you can just know which questions to do first. 5 minute per yeah, it's 5 minute. Yeah, so stuff like that. What else? What other techniques? The complex number. Yeah. So just letting you guys know, I didn't do a polynomial complex number one. Because they always like to shoot that one as well. Which one is it? Question 3? This one? Graphing. Yeah. So there you go. All right. What else? Don't do an exam paper tomorrow. Like, just don't. I recommend just going through multiple choices as like, just warming up your brain for the morning. But other than that, just don't do a full exam because that would completely muck up your mental when you get in. It's only tech free tomorrow, isn't it? So that should be okay. What other tips do I have? Yeah, I don't know. I feel like you guys all have your exam rituals as well. Mine was eating an apple before my exam, so do that as well. Because I don't know, slow release sugar, whatever. Apple water. I would also bring my watch into the exam and place it on the right side. Yeah, I will send this doc through. Well, I'll give it to Ollie, and then he'll probably post it on the study hub. But yeah, what else? Oh yeah, I don't know, don't do pre-workout before. That's just kind of dumb. I feel like if you do that, just get really hyper, but you've got to time it correctly. I don't know. Some people did pre-workout before and it was kind of like just really stupid. No. Honestly, yeah, you could. I think one of the gym rats in my grade did go to the gym before their exam. It actually helps because it makes you it gets your heart rate up. So you start, yeah, more weight. Exactly. So could honestly do a pump. I don't know, don't go for PRs then. Bench PR. Yeah, probably don't do that. Like yeah, you guys honestly should be fine. I'm hoping you guys do well. Specs scaling is always quite good. So if you think when you walk out the exam and you get like 60%, that's probably like a maybe 40 low 40s, 42, 43 out of 50. Because I know 40% is like the average, and so they give that to 30, like a raw 40% is like
Wait,
38 out
actually?
of 50. I think.
Wait, I'm not cooked. Let's go.
Bro, where are you getting
Yeah.
this data from?
I think that's the scaling because
Yeah, QTech releases their results for
yeah,
scaling every year. So
yeah, so like a raw 40% on the exam. So if you think you like completely mocked it, I think because that's the average because they do it based on the curve, right? So if everybody just like does really badly, how do I know that? My teachers told me. He marks the exam, so yeah.
Wait, so what does 40% get you?
Like if you get I think if you like get 40%, it will transfer to a 38 out of 50 when they scale it.
What?
Yeah, I'm pretty sure that's the case. You don't get like a 25. You get a 25 out of 50 if you like basically wrote nothing on the exam. I'm not lying. Trust me. One of my mates completely. Yeah, don't quote me on this, but I'm pretty sure that's the case. Because our specialist fair is just not fair. Because I'm pretty sure yeah. So yeah, what am I meant to say? So yeah, but always like I guess hitting 50 out of 50 is always a bit hard. Like you do need to get like I don't know, 80%, 90% even. 100, nah, no way. Yeah. I think I did like quite mid. I got 47 on the exam. So it's like maybe I got 70% or 80%. Something like that. So yeah. It's kind of I think that's how the scaling goes. Yeah, what else? From memory, my exam was quite vectors heavy. So I don't know if it was going to be very vectors heavy again. Um, Especially on paper one, there was a lot of vectors if you've done the 2023 paper one. So they might. You're gassing everyone up by lying from the I'm not trying to lie. No, you guys will do fine. Um, yeah. Did I do physics? Yeah, I did physics. I got 49 out of 50 on that exam. Because it
Well,
was
Did you
did you
graduate last year?
graduate last year?
Yeah, I graduated last year.
Oh, you got
Hell
lucky, bro.
nah.
2022 and
Yeah, if you
absolute
guys,
bad
I don't know what happened to your physics exam because some of my students were like, bro, that electromag question was
it was
hard or something.
worse than 2022.
Oh, surely not. Like I think you guys had a lot of graphs because my year there was not a single graph. So that's why they brought graphs back, I think.
I thought they were removing it altogether, bro.
Not because I remember the last time there was the graph, it was like 2020, right? So you guys thought it wasn't gonna be on there.
No, 2022 had a bunch of them, and then they removed them all for 2023.
Yeah, so I guess expect the opposite.
So stupid.
Like they kind of like alternating things. So
Was spec hard last year?
last year it was like spec wasn't too bad last year.
We're cooked then.
Physics scale well. Okay, here's the issue. Like, if you guys read the report, like I think the IA 2 and 3, you know, the most like apparently like the most common mark is like a 20 out of 20.
Yeah, bro. Internal mark is so
because
rigged.
because basically like the internals are pretty sketchy, especially if you come from a private school. It's like basically everybody goes into the exam with like 50 out of 50 internal marks, and all they need to do is the EA and
It's
do
so stupid.
somewhat well.
For specialists, I think
What
like
at
almost
Somerset?
double.
No, definitely at Somerset.
Oh hell no.
Yeah, like we got in overall our grade out of like 160 people, we got 20 that was a 99 and over, 20 people. And then from that, it was like a median of maybe 90, something like that.
Bro, what school did you go to?
Somerset College.
Somerset, bro.
It's on the Gold Coast.
Wait, Ollie, I'm curious, like quickly, so we don't waste everyone's time. How does everyone get 50s? Do the teachers just mark them so easily, or like because?
Your mic is so shit.
Sorry, my bad.
Bro's in the basement.
Okay, it's not the. I probably shouldn't do this on recording, so I might stop the recording first and then tell you guys. Let me just how do I stop recording? I'll stop sharing screen first and then stop recording.